Hello and welcome back to another video on what is a mole. This is a concept which many students find difficult to understand. So here we'll try to illustrate it with an example. Uh, as highlighted in this objective, the mole is the unit of the amount of substance. I would rather say it's the SI unit, the System International Unit. So in simpler terms, the amount of substance would refer to that how much or how many something is present. Just like in daily life example, you say how many tomatoes are present or how many potatoes are present. So over here too, it's like how much amount of that particular substance is present, or in other words, how many particles are actually present in that amount, whichever is specified. So that is equivalent to 6.02 into 10 to the power 23 particles. So one mole contains this much amount of particles, and this is kept at standard to define the definition of one mole. That is, which contains this number of particles. This is also known as the Avogadro constant. So at many places, you would also have seen that this number is actually equal to the number of atoms in 12 grams of carbon 12. So this is actually the standard which was set from which the definition of mole is derived. So here I would like to illustrate an example uh, to make you understand what this mole is. This is not the fact how SI units are derived. This is just for the sake of understanding that how that what mole actually means. So when the scientists actually sat down to define mass and to set a standard, an SI unit for the mass, we are assuming that what they took is that they took a block of iron and they a random block of iron and they weighed it, and they just whatever the weight came in, they just said that they gave it the name that this would be called from today onwards as 1 kg. So anything which was equivalent to that particular mass which they had kept as standard, that would be equal to 1 kg. If that may be 1 kg of potatoes, 1 kg of tomatoes, or 1 kg of wood, or 1 kg of cotton, whatever it would be, that was kept as the standard. If the weight was 1,000 times of whatever this came in, that would be called as 1,000 kg, and etc. etc. Similarly, when the scientists set out to define length, we are assuming that they took a random rod of wooden stick and they measured it. So whatever the measurement came in, they set it as to be defined as that this would be called as 1 meter, whatever that length was. So when they kept this 1 meter as standard, now whatever rod there is of that length, whether it be a wooden rod, whether it be a steel rod, whether it be an iron rod, if the length is equivalent to this one, that would be called as 1 meter, because that 1 meter was now kept as the standard for length. Okay, similar to the way that the scientists defined the SI units for mass and the length, they sat down to define that how we are going to count the amount of substance. So what they did is that they took carbon 12, they took exactly 12 grams of it and kept it in a machine. I'm just assuming that this is a machine which can count the number of particles in whatever the substance is put inside it. So, for instance, a particle counter. So when they placed 12 grams, they saw that the machine showed the reading of 6.02 into 10 to the power 23 particles. So they now kept this as the standard and said that now whatever amount of any substance, whether it be sulfur or oxygen or sodium, which would contain this much number of particles, we are going to call it 2 as 1 moles. So they kept this as standard, and anything equivalent to this number of particles would also be called as 1 mole. Just like any mass equivalent to this would also be called as 1 kg, and any length equivalent to this wooden rod which they initially took would also be said as 1 meter. Similarly, any amount of substance which this machine showed as 6.0 to 10 to the power 23 particles, that would be called as 1 mole. This was kept as the standard. So the scientists then began to see for the other elements. For instance, if I'm saying that they wanted to see sodium, they started putting sodium inside it and see how the number rise. So as they pour in sodium, the number rise from one particle, 10 particle, 100,000, 10,000. The number increased until the number reached 6.0 to 10 to the power 23 particles. So when that amount of sodium came in, they said, okay, so we have reached this number of particles. So this is exactly 1 mole of sodium. So 1 mole of sodium was found in this machine. And then they said that, okay, now let's wait that how much mass it has. So this mole amount of substance and mass has different quantities. So they said, okay, come on, let's wait and see what comes out. So then when they weighed this 1 mole of sodium, which they found in this machine as having 6.02 into 10 to the power 23 particles, they found that it came out to be 23 grams. And when they similarly placed magnesium in this machine and they just continued adding magnesium until this value was reached, that is 1 mole, and then they weighed it, they found it came to be 24 grams. And similarly, if they did it for aluminium, they found that, and later on weighed it, the mass came to be 27 grams. So they were surprised to know that whatever mole they took of any substance, the mass is actually equivalent to the AR of that particular substance, that is the relative atomic mass. So for sodium, if you see in the periodic table, the relative atomic mass is 23. So 1 mole of sodium is 23 grams in weight. And this was found by experiment. And similarly for magnesium, if the relative atomic mass is 24, on the periodic table, 1 mole of magnesium is exactly 24 grams. So you just take that AR, or if you are taking a molecule, for instance, 1 mole of MgO, um, a compound, not a molecule, a compound, MgO. So this is 24 AR and this is 16. 24 plus 16 makes a 40. So when MR, that is relative molecular mass of MgO, is, in this case, the relative formula mass is 40. So 1 mole of MgO, when they weighed it, that was exactly 40 grams. So the scientists got to know that whatever substance they are taking in, an element or a compound, and if they weigh 1 mole of that on this, they find the mass of that. So that is exactly equivalent to the AR or MR of that particular substance. So in summary, this is how mole is defined. This number is taken as standard to define mole. Any substance having 1 mole of particles is equivalent to 1 mole of amount is equivalent to this number of particles. And 1 mole of every substance would have a different mass, because mole and mass are different quantities. The mass and amount of substance are different, and whatever the masses come of different substances, they are equivalent to the AR or the MR of that particular substance, which is given in the periodic table, and you can find from there. So thank you. That was enough.